Okay, good morning. So let us actually continue the very important lesson of applications of derivatives. I hope that you could remember what I told you before about how we can precisely determine the exact points of the exact extreme points of a given function. Of course, at this level, a function given to you should be a well-behaved function, meaning that it doesn't have any sharp points, and it is continuous. Yes. To refresh your memory, if you don't mind, let me try to solve some of the problems. I have already updated the Google Classroom on which parts you're supposed to work. But let me solve some of the problems here. We can actually solve it together to learn. By the way, I forgot to say, people at home, can you hear me?
Yeah, we can hear you.
Okay. Can you also see the board? Can you see the board?
Yes, we can.
Thank you. Okay, so this problem, let us take it. This is a level 1 problem, and that's a good one. This is probably to write a number. Let me don't start with a very, very simple one. So problem 3014, let me take part B. And the given function is f of x is equal to x squared divided by 6 minus 3. Oh, sorry, that is not x squared, that is x cubed. That is x cubed minus 3x squared divided by 2. And then I have plus 4x plus 1. And more or less the same thing if I understand it Swedish correctly. So we want to use the method that we learned about the sign tables and whatever to determine the local extreme points or terrace points, if any, of this function. Yes? So do you remember what we're supposed to do? I told you that this is more or less an algorithm, but you need to review it in your head. So what was the first part of this? Yes?
It's the prime function.
So we find the prime function, so f prime of x. Hopefully it is not hard for you. What is the derivative of this in your head?
It's 1 over 6 times 3.
1 over 6 times 3 times?
What?
1 over 6 times 3 times?
3 times what?
X squared.
Okay.
Yes? But then 1 over 6 times 3 is just 1 over 2. Yes? Yeah. Because if you don't respect that every time, you should write 1 over 6 times 3. Okay, 1 over 6 times 3 is 1 half. It becomes x squared. Yes?
Yes.
Is that understandable? And then what is the next one? Minus. You know that 2 is supposed to go down. Yeah. But this 2 that is gone, it's down now. By that 2 are cancelled. So what is left?
Negative 3x.
Negative 3x. The derivative of this one is nothing except 4. And the derivative of 1 is 0. That's the first step. The second step is to put this equal to 0. Why? Because by that imagination, it is easy to see that the local extreme points are among the points that the tangent is horizontal. When the tangent is horizontal, it means that the derivative should be equal to 0 at that point. So then, if I put it equal to 0, then what I get is 1 half x squared minus 3x plus 4 equals to 0. I don't know, but for me, I would prefer not to work with fractions. So what I do, I multiply this by 2. Okay? I multiply this by 2 to get rid of the fractions. This becomes x squared minus 6x plus 8 equals 0. You can use PQ formula, ABC formula, and if you are actually quick in factorization, probably that is better, especially for these small numbers, yes? Can you factorize it? If you want to factorize it, we learned it in the first chapter. You don't have to. If you are not comfortable with factorization, you can just use ABC or PQ formula, of course. But then I put an x here, another x there, and I ask myself, I need a number, I need numbers whose 2 numbers actually. The sum is minus 6, The product is 8. If I can guess, I am done. What are those numbers?
Minus
Yes.
2, minus 4.
Minus 2, minus 4. But be careful. The numbers, the roots are not minus 2 and more, because you put them equal to 0, then you move them to the other side to find x. So then it means that x is 2, x is 4. Don't get confused. The sign of the roots are different from the signs that you guess for the numbers. Or actually not different, they are opposite to that. If I ask you what are these in the boxes, I would say that up to this step, these are just they are candidates for possible local extreme points. There is no guarantee that they are really the real ones, and even if they are, we don't know which one is which one is max, which one is mean. To explore that, we have to set up this, which we call the sign table for the derivative. Yes? So, and this is convention. I told you the first row is taken to be x. And I think it's a very bad convention, isn't it? It might be. Naturally, probably people prefer to have y below it. I don't know. But let us just follow the convention. So this is f prime x, and this is f of x. So the numbers that I got here, I should arrange them on the first row in ascending order, from the lowest one to the highest one. And then you don't need to really calculate the numbers for the derivative at these 2 points, because you yourself put the derivative equal to 0 and got those numbers. It is completely clear that if I put these numbers in my derivative, I will get it 0. But here you have more or less the calculation here, and this is not really very friendly usually. So I have to put this number 2 inside my function. So if you want, you can go to scratch paper and replace x everywhere with 2. So let us do some part of it in our head at least. So 2 to the power of 3 is 8. 8 divided by 6, I simplify it by 2, it becomes 4 over 3. Yes? I put 2 here. 4 times 3, 12, divided by 2, 6. I put 2 here, is 8, and then I have 1. So this becomes 9 minus 6 is positive 3. Okay? And then hopefully you agree with me, and the answer should be this, yes? Because up to here is what? 3. And then 3 times 3 is 9 plus 4 is 13. So the answer that I get here is 13 over 3. And I have to do this one again. So I replace x. Be careful, don't get confused. You have to be careful. Sometimes I myself make mistakes. Be careful that which row you are working. You are working with the row of f. So everything that you want to get, you have to plug everything in the row, in the function itself, not the derivative. Okay, so let me put 4 here. 4 to the 3 is 64 divided by 6, which is how much? 64 divided by 6, it is 32 divided by 3, if you simplify. 64 divided by 6. And then I put 4 here as well. It becomes 16 divided by 2, 8. 8 times 3, 24. I put 3 here, 4 here is 16, and then 1. And this time, what is the answer? It's minus 7, and then it becomes 11 over 3. So you see, don't consider this being distracting you. So these are just simple arithmetic calculations. Because this is a well-behaved function, this is the bad thing hearing from a teacher, because I'm just learning you to cheat. So here, this number is bigger or this number is bigger?
The left one.
The left one. So from the bigger one, we are going to the lower one, so this means that the function is going down, so it is decreasing.
Mm-hmm.
But the logic is the other way around. You need to find the sign for these, yes? So if I want to know the sign here, I choose a number smaller than 2. For example, the best choice is 0. It's easier. Where should I put it if I want to know the sign here? Should I put it here or in the derivative? In the derivative, because this is the derivative line. So I put 0 here, I get 4. 4 is positive. Then I choose between 2 and 4. A random number, a good pair. What is that?
3.
3 is best. But where I put it here. So let us you don't need to calculate, you need to convince yourself. If I put 3 here, it becomes minus 9. Plus 4 is minus 5 so far. But this becomes 9 over 2, which is 4.5. Minus 5, 4.5. So it is negative. And that was exactly according to your prediction, yes? And then after 4, choose a number, 5, and put it here. You just need to convince yourself. So 5 to the power of 2 divided by 2, let us just write it here. This becomes 12.5, and then minus 15 plus 4 becomes positive. So then this goes down, this goes up, the function on this interval. Which interval I mean? I mean every number less than or equal to 2. Another interval that I have here is between 2 and 4. Another interval that I have here is greater than or equal to 4. So these are the 3 intervals. Even though I don't write them like this, some books, by the way, they write it like this. I don't like it because you have to write a lot of things. But anyway, this is increasing, this is decreasing, and this is again increasing. And then it is clear that which type of point is this point? It's of this type, which is this is maximum. Yes? Local maximum. And this one is local minimum. So good point is that we do not have any spy here today because all of them are real. Yes? So you should write them down. If I ask you for the points, you have to give me x and y. Yes? So 2 and 13 over 3. Local, what type of that one? Local max. Yes. And then this one, 4 and this local min. And that's exactly what we are supposed to solve for this problem. But at this point, you might have a solution which is completely, you might have a question which is very reasonable, but I don't know why didn't you ask that question.
What's the question?
What's the question? What's the question? The question is that what's the question? Yes? What is the question? What? You should have the question. Because I am selling things to you, you know. You have to be careful about it. Yes.
So a point after 4 maybe?
No.
No?
No. So here, if I wanted to find these signs, what did I do?
Oh, you took
I took a random number here.
Yeah.
For example, 0. I put it here, it turns out to be 4, and then I say it's positive.
Oh, okay, I think I know the question.
What's the question?
What about positive and negative infinity?
No, that's not the question.
Okay.
What is the question? Yes?
How do we know it's true for all numbers?
That is the question. But you didn't ask. I just put 0 there, it turns out to be 4, and I used your naiveness and said that, okay, this is always positive. How many numbers I should check?
All.
Which is, how many? Infinitely many, but I checked only one of them, and then you were actually very good customers. Actually, you immediately paid that. Yes. So this is not trivial.
But it's clear that...
No, it's not clear because it depends to one important property. Not every function has this, and that is exactly the reason we have to do this first. But otherwise, I really don't need that. Let us look. If this is minus infinity, let us put minus infinity here. what would be the final result? Of course, minus infinity is not a number, it's a behavior, but you already know what to do. When you want to put minus infinity here, which one will dominate the highest power? So immediately in your head, clean this and put minus infinity here. It becomes what?
Minus infinity.
Minus infinity. Yes?
Yeah.
And then go here, this is plus infinity, and put plus infinity here. Again, which one will dominate? Forget about the lower terms, and then consider here. What will happen?
Plus infinity.
Plus infinity. And now look. Do not look here. The y value was minus infinity, but it has reached to this value. Can the function decrease? Because if you are at minus infinity and you decrease, you go to hell, yes? There is nowhere to go on. But when from minus infinity you have reached to this, it means that you have increased. Yes? So then I can just calculate this, and I say that this is increasing, and I have reached to this. And then this is a number, this is a smaller number, so it is normal that I have decreased here. And then again from this number I have actually gone to the infinity, so it means that I have increased. So I can cheat. Yes? I can write this and then write this. Then the poor teacher we're correcting doesn't understand which one you have done first. Yes? I will assume that, okay, you have done it logically. But what I want you to say that, first of all, I want you to understand this a little bit better. Of course, you will not face such a problem. But I want you to at least understand if someone else asks you why is the guarantee that you just choose a random number 0 here and then put that one single number there and then suddenly claim that every number that I choose and put it here, it turns out positive. There is a reason for that. What is that? We can't. So can you imagine a function without this property? Yes? So what I'm saying is that this, you see, if I have a function going from a negative y value to a positive y value, it might be like this. Yes? Do I get some 0 in between? If I ask you, do you see any 0 for this function on this picture? You say no, because you don't have any intersection of the graph with the x-axis. Yes? The reason that this happens is because the function is not continuous. But if I'm not allowed to raise my pen from the whiteboard and I want to go from a negative value of y to a positive value of y, it's inevitable. I have to cross the x-axis. Yes? So then, if I go from here to here, there is no way. If I want to go continuously with one pen stroke, it's inevitable. I have to cut it somewhere. And that's exactly the same thing. This function, the derivative, is a polynomial in this case. And you know that polynomials are among the best well-behaved functions. They are very polite, yes? So that's continuous. And now I am saying you, at 2, this function is 0. So you see, when you have 2, this is a function which is continuous and cuts the x-axis at 2, yes? Okay, now I am telling, yes. And now I told you choose a number random here. You chose 0, and you put 0 here, you got 4. So this means that when I put 0, it becomes 4, somewhere here. Yes? Is that right? Now, and I want to claim that this remains always positive. Why is that? Why is that? Because I don't know what is the graph of this function, but they are connected somehow. And then I want to tell you that there is no way for this function to come back and becomes negative. It will remain positive. Why is that?
Because the derivative of this function has only 2 roots.
Only 2 roots. Exactly. There is no other roots. Yes? So if it is going to come back and if it is going to become negative at some point, it has to cut the x-axis at some point. So let us repeat myself. I chose 0. I calculated this for 0. I got a positive number. I am claiming that, don't worry, any number that you choose smaller than 2, this becomes positive. Why? You might say no. How do you know? I would say yes, because if it is going to be negative, 4 is positive. If I am going to be negative at some point, because this function is continuous, it is inevitable. This function has to cut the x-axis at another point. But I know that these are the only cuts of this function. But this is not possible. So if someone asks you why this is true, you should tell them that because of continuity of this function. If this function is not continuous, there is no guarantee for that. Yes.
What should we do if you have a constant, if you have a function which is discontinuous?
That's what I'm saying. If the function is discontinuous, the logic is do this one first and go here. And in that case, you have to convince yourself what will happen. Because usually when you have the discontinuous function, discontinuity is happening at this point, but the rest of the branch is continuous. So you might have a discontinuous function. So this function, I will call it discontinuous. This function in total is discontinuous, but each piece is continuous. So you have to have this idea for each piece. But don't worry about these things, but when I'm teaching, I want you to learn, because this is not trivial. I chose one number, I realize it is positive, I am claiming that, don't worry, it remains positive if I choose every other number. The short answer is that, because I am at the positive point, the y value is positive, if it is going to be negative at some point, because the function is continuous, it should cut the x-axis at another point, lower than 2. But you know that there are only 2 zeros for this function. I do not have any 0 lower than 2. Yes?
Can a continuous well-behaved function intersect itself?
No, the intersection of a function, that is not called a function at all. Mm-hmm. So for example, if you have something like this, I don't know, if I draw the graph of this function, something like that. That is not a function at all.
What is that?
That is just a relation. Because function is a set of pairs. So when you have a function, I don't know how much you remember from what I told you before in math. So if I have a function, mm-hmm. I have 2 sets of points, and then I am assigning them. But there is one important constraint. You are not allowed to assign 2 different values to the same point.
Okay. If
this happens, this is not a function at all. In this case, this is happening. Why? Because, for example, if you say this is a function, okay, mm-hmm. Let me give this as a 2. Let us call it the function f. If I ask you what is f of 2, what do you say?
Well, it's the height.
It is this one, or that one. Because if you do this, you will get confused, and that is the property that we want to exclude from a function. A function is a relation, is a rule that assigns one single element to each element here. But here, if this is going to be a function, then this number, for example, let us say that this is 2, let us say that this is 4. Then 2 is assigned to 2, and 4 is also assigned to 2. So this graph is not the graph of a function at all. And all the things that we are talking about, limits, functions, so limits and derivatives and whatever we study here are only for functions. Yes? But of course, if you want to understand the behavior of that, you can cut it so that it becomes a composition of different parts, which each part a function. For example, I don't know, might be you can concentrate on this part, which is a function, mm-hmm. And then, for example, how can I discuss? Can I find a way to do it here? yeah, then I have to cut it from here, and then, I don't know, cut it from here. Yes, somehow, so you mean that each part that I am talking right now is a function, yes?
Yeah.
This one is a function, I don't know, this one is also a function. But if I combine them, the whole thing is not a function. So if you want to analyze the property of this shape, you can break it into parts, which each part being a function and discuss about it. Okay, but don't worry about these technical things. I want you to understand things deeper, but now you are safe because you are always working with well-behaved continuous functions, so this is always working. But this is not guaranteed if the function is hardly reversed. Okay. Let me see what type of questions you might face here. So there are some star problems here. I don't think you have difficulties on this standard problem. Yes. So they give you a function and they ask you the terrace point. That is also good. I don't know. They haven't provided any example of the terrace point. Unfortunately, I have to solve it to see which one has a terrace point.
Maybe you can look at the answers.
Yeah, that's a good idea. Let us see. It's better to solve one more problem regarding the terrace point.
Social notes? That's a social notes. Okay.
No, all the examples that they have provided.
You solved the problem with the first one.
Yeah, I remember, but I was thinking that might be a good idea to solve one more. Okay, let me give you another example myself. So, let us take this one. F of x x to the power of 3 minus x to the power of 4 plus 1. I hope that this is correct. Yes. Okay. So if I want to do the same thing for this new function, no? So the first thing is to differentiate the function. This becomes 3x squared minus 4x cubed. And then I equate it to 0. By the way, I can use this to see. The derivative equals to 0. I get, what are the answers? Okay, how should I solve that? I need to
You can factor.
factorize. Factoring x squared out, this will give me 3 minus 4x. This is equal to 0. Then this means that either this one is 0, which means x is 0, and this one is 0, x is 3/4, yes. Okay, so now, let me at least draw a line here. And now I set up my table. X from minus infinity to infinity. By the way, you don't need to bother about this infinity when you want to solve this problem. If you write it, it's not wrong, but that is a little bit extra work. You don't need to do that. So 0 is the smaller one, 3/4 is a little bit larger. This is derivative, this one is this. And then I get 0 here, 0 there. And then I put 0 into my function. This becomes 1. I have to do a little bit of work here. Scratch paper, I have to replace x with 3/4. Raise it to power 3 becomes 27 over 64. Raise it to power 4 is 81. And then this is 256. And then I have plus 1, yes? Okay, and then the common denominator will be 256. 4 times 80, 108 minus 81 plus 256. So what is that one? This is 19 and 8 is 27. If I add it here, I don't know, hopefully I am right, yes. So 108 minus 81 is how much? 27. 276 and 7. Yes, I think that's correct. So that number I have to put here. So if you want to do some cheating, is the function increasing here or decreasing?
Increasing.
Increasing, because this number is definitely larger than 1, yes?
Yes.
Okay, but that is not cheap, okay? This is a good question here. So now, be careful. This is the only thing that you have to be careful when you are dealing with terrace points. So here, I choose a number, a random number, that at least you understand now why this random choice works. But I choose a random number before 0, which is minus 1 is the best choice probably, and put it where? I want to decide the sign of f prime, I put it here. So minus 1 in your head, put it here. It becomes positive 3. This becomes what? Positive. So it is 7 and it's positive.
Wait,
No, wait.
it's negative.
No?
Yeah.
It's an uneven power of negative 4x3.
This what?
No, the
No.
other.
4x cubed.
I put minus 1 here.
Yeah?
So this becomes 3, this becomes 4.
No.
Why
Jo,
not?
det är minus.
This is minus,
Okay.
another minus comes from
Okay.
it. Yes?
Okay.
Yeah, that is positive.
Okay.
And now let us choose, and this is the really bad one. And I want you to tell how to avoid. I would never do the random point here. Because what is the random point between them? 3 over 8, for example. I don't know what you want to choose. It's a bad one, yes? But I prefer not to do that because I'm a human being and I'm smart probably. I will go
You can
here.
just choose
yes?
0.5.
I will factor is this one. I will
Or
3.
one.
So 3. I take x squared out here. So it is 3 minus 4x. So you see, for solving the equation, I had to factorize. But you don't have to factorize the derivative. But if you factorize, you can answer these sort of questions easier. So now can you tell me what will happen here? The derivative includes x squared. I really don't bother about x squared because x squared is always non-negative. So I need to only care about this part. If I put 3/4 there, it becomes exactly 0. What do you think will happen if I put a slightly smaller than 3/4? What do you think? If I put 3/4, this becomes 0. But I am putting a little bit smaller than 3/4. What is left? Positive will be left or negative?
Positive.
Positive, yes. So this becomes positive. And don't get confused. Don't think that they will always go alternatingly. Yes, they will go alternatingly if you have local maximum min, but if you have a terrace point, that is the indication.
Yes.
And then if you go after 3 over 4, let us choose 1. If I put 1 here, this part becomes negative. This is always positive, so it becomes negative. So here, the function is increasing, but suddenly the function decreases. So this was the mole, yes?
Yes.
Yeah. So 0 and 1 is neither max or min, it is a terrace point. And then the other point is this very strange point, 3/4 and 283 over 256. What type of point is?
Max.
Max. And please write local max. So far we haven't talked about global max, but we will soon see about that. So Yes?
How will the graph of this one look like? The graph.
So if you want to see the graph, that's a good question as well. But of course, unfortunately, these numbers are so nasty. But here, in the graph point, I recommend you to bother a little bit extra work with minus and positive infinity. And that is not hard. You go here, because this is the f of x line, you have to answer everything related to this line using this. What do you think I will put here? Which one will dominate? The highest power. So ignore these. And then minus infinity to power 4 is positive infinity, but there is a negative sign here, so it becomes negative infinity.
Yes.
And if I go to the right-hand side, what will be the answer? Here?
Negative.
No?
No.
Just go here, put positive infinity.
Yeah.
Which one will dominate? This term. Positive infinity to power 4 is a huge number, but you multiply it by a negative sign, it becomes a huge number, but a negative huge number.
Negative infinity.
Yes.
Yes.
Okay, and then try to locate the points. So here I have 0 and 1, so this is a little bit hard. No, it's not hard, that's not a very big number. So 0 and 1, let us consider this one. In the terrace point, I recommend you to just draw a very small horizontal line in your head. And then, what type of terrace point is this? Because we have two types. One of them is this type, one of them is this type. Which one is this one? The left one, because it's always increasing. So it means that around this point, you expect that your graph looks like that. Yes? And then you need to go to the max point, 3/4 and this one. You really don't need to be... This is important, that this is a little bit above 1. So for example, let us consider, to exaggerate, it doesn't matter, you can rescale the scale, the axes. So this number is 283, 256, and then this number is 3/4. So for example, if this is 1, this becomes 3/4, for example. And then I have this point. But this is a max point. Around the max point, you have this scenario. Yes? And then it becomes clear what to do, okay? So this means that I have to go from here and connect this and then come back. But how? According to my calculations, the fun part of this function only appears here. The rest of it is boring. Why? Because when I reach this threshold, it will continue to go to the hell, yes?
Yes.
Yes, it will continue. Nothing we can do for this poor function. So it will go there, and then... Okay, but that is not a big problem for this function, because the function arises from the hell and go back to the hell, yes? So here, this function goes down. So something like this. But of course, I can make it a little bit better. I don't know how it looks on GeoGebra because I am rescaling it a little bit. We can test the idea if you want to, but what is important is that, first of all, these are not easy to locate exactly. GeoGebra can do that by just numerical calculation. Why is that? If I want to find exact points here, what I'm supposed to do? Just tell me what to do to get them. But you will see that this is not practical for us. If I want to get the exact value of these, you need to answer me in a matter of seconds. These are zeros of a function.
Yeah.
If you want to find the zeros of a function, do it. Put the function equal to 0 and find it.
Y-intercept.
No, y-intercept is this one.
X-intercept.
Y-intercept is always easy, because you need to plug 0 in the function, and you get the answer. That's the y-intercept. I always prefer to have it. But for the intercept, I am not very sensitive, because if I want to do that exactly, I have to be able to solve this equation, which apparently I really don't know right now. Might be, not me, because might be this is possible to factorize, I don't think. By the way, according to this problem, you see that this is a very good thing, by the way. Very good thing. Now I realize, if I ask you how many solutions are there for this equation, what is the answer now? 2. But if I ask you solve them or find them, it is not possible. By the way, the degree of the polynomial is 4. You might expect up to 4 roots. But for some reason, it is not possible for this. Because we are completely 100% sure at this stage, there is no possibility for having 4 roots for this. Because I see the graph in front of me, there is no returning back. Because if I want to have more roots, one of them should go back and intersect. But it is not possible because if it goes back and intersect, it should have a local minimum somewhere else. But it doesn't. I want you to understand, we are doing a very great job here. It's not just guessing. Is that clear? Okay. So I hope that I could answer you, Zohar, that is the graph.
Yeah, one more question. Shouldn't the graph have the same roots as when we counted? Like x equals 0?
No, that is the maximum. No. When you repeat here,
Yeah.
no, there is no guarantee.
Okay.
So the numbers that you see here is related to these interesting points. So these numbers, yes, you can say that if I have 5 of them, then I have 5 interesting points on my graph. Yes, this number. But these intersections are not related to these numbers, are related to the roots of the original function. Is that clear? Okay. Another type of question that I see here, let us solve them. I don't know, they have some stars on them. Okay, because I don't want to solve all of them myself, let me choose and then leave some of them for you to practice. Okay, so let me go back and the other one. Another type of questions that usually they consider it a high-level question, not necessarily hard, but I want you to understand. So this is question with 1 star, 30-20. A function is given to you, f of x equals to ax cubed minus bx squared plus 2. They say that this function has a local extreme value 6, a local extreme value 6 at x equals to 2. Determine, so let me write, what is A, what is B? Yeah, this is a very simple question. Actually, you had this question in the exam. Yes, but I didn't ask you about this term, because you didn't know probably about this term. But what I want to do is exactly the same thing that you did in exam, the first A-level question in the exam. Yes? So here, you want, there is no guarantee. This is a function. There is no guarantee the local extreme value of this function is 6. By the way, they have mentioned extreme value, which we don't know. Is it a minimum or maximum? But I know that an extreme point, either a max or a mean, with value 6 occurs when x is equal to 2. Using this piece of information, we should be able to find A and B. And now, of course, we can continue the question at the end and then say that, okay, after determining A and B, go back and determine the nature of this extreme value. Is it a lot? But they haven't asked that. Okay, so what should I do? So you see, if I ask you, if I want you to write the word local extreme point, is what?
6.
No, local extreme
2 and 6.
point. 2 and 6.
Yes.
Okay. So, a local extreme point, first of all, is a point on the graph. Yes? So it means that its coordinates should satisfy the equation of the function. Yes? That is without derivative at all. This is not, I cannot communicate.
Should you plug in 6 as f of x and 2
Yes,
as x?
yes. So let me write it here so that you are not confused. Okay? So, yes, you are right. First of all, I don't use the derivative at all because I tell to myself that, okay, local extreme point is a point on the graph, so it means that the coordinates should satisfy the equation of the function. So it means that if I replace x with the x coordinate, what I expect to get is the y coordinate. So it means that 6, so let me write it in this way. A, 2 to the 3, minus b, 2 to the 2, plus 2. By the way, these harder questions algebraically are simpler, but conceptually might be a little bit harder. So this is 6. The algebra involved is very trivial. This is 8a, minus 4b, and I move 2 to the other side, it becomes 4. And I never stop here. I can divide by 2. So this becomes 4a. Let us avoid this. Might be I have to multiply by 2 at the end. But let us just keep it like this. This is one equation. Now, you don't expect to solve it because there are 2 unknowns. So you need another extra piece of information. And that is provided because any point on the graph have this property. Not just local extreme points. Any point on the graph with these coordinates will satisfy that, regardless of this is a local extreme point or not. But now, okay, can you help me to do the other part? So how can I find another equation?
Take the derivative.
Okay, just complete. Derivative and then?
Maybe after that you put in 2 for x, but you cannot really put in 6 for f of x.
But we have to do something.
Put in 0.
Okay, but why? Confidently. Yes,
Well,
0 is correct.
The derivative of 6 is 0.
No. You're going to the wrong direction.
Okay.
So what you said is that take the derivative. Okay, I will do that. It becomes 3ax squared minus 2bx. And then you said that f prime of 2 is 0. And I agree with you, yes, but the logic was wrong. Alright, I understood it wrong. This is the case, yes. Why?
The key value of the point is 0.
Yes, because when you say it's a local extreme point, it might be a max or it might be a min, but in any case, the tangent is horizontal. When the tangent is horizontal, it means the slope is 0. So
Okay.
this 0 is not because the derivative of 6 or whatever is 0.
Okay.
It's because it is a local extreme point, so the tangent is a horizontal tangent. Whenever the tangent is horizontal, it means that the derivative at that point is 0. So then it means what? It means that I replace x with 2. The answer is supposed to be 0. This becomes 12a minus 4b equals to 0. I move 4b to the other side and divide by 4. So this becomes 3a is equal to b. Okay, now I have 2 equations and 2 unknowns. I set up a system and solve it, yes? So this becomes, and now I am on the safe side. Let me just divide everything by 4, yes? Then it becomes 2a minus b is equal to 1, and then I know that b itself is equal to 3a. But this is usually this is very simple to solve these systems. So I replace b with 3a, so it becomes 2a minus 3a is equal to 1, so minus a is equal to 1, so a is equal to negative 1. And then I plug it back here, b becomes negative 3. So what does it mean? It means that if you replace a with minus 1 and replace b with negative 3, So it becomes this. And if you use, for example, GeoGebra to draw the graph of this function and just go to this point, you see that this point is a local extreme point on this graph. But which one is not clear yet? Now we can answer that one. So I extend the problem a little bit after the book. So now that we know that, I want to go back and determine the nature of this point. What is the nature of this point? They have mentioned it's an extreme point. Is it a max or a min? How should I answer that?
Draw a sign.
We have to draw a sign table, but because I don't want to locate anything, you don't need to write the entire picture. So what you need to do, the x coordinate that you are interested in is just 2. You know that the derivative is 0 here, and then you know that a y value is 6 there. It might happen that you have other points somewhere else, but we don't care because we just care about the nature of this extreme point. We might have other extreme points somewhere else. We don't care about them. So then tell me, how should I know that the derivative is positive or negative before 2? So I take the derivative, it becomes minus 3x squared plus 6x. I factor a minus 3x out, it becomes x minus 2. Okay, so the roots are 0 and 2. So you see the other one is 0 that I don't see. So choose a number between 0 and 2. For example, 1, put 1 here, then this becomes positive. And choose a number larger than 2, for example 3, this becomes negative. So it goes up and down. Then it becomes a maximum. So this point is actually a maximum. We will learn a faster way to do this part. That is, so you know that, by the way, I forgot to mention it again today. Last time, that algorithm that I used to detect these points was called the first derivative test. There is another version which we will learn, and that's called the second derivative test next time. Mm-hmm. That part, if you know that part, you can do this easier instead of drawing the sign table.
How did you conclude that there was a negative after?
This one, I chose a number larger than 2 and put it in my derivative.
Okay.
This one becomes positive, but this one is negative, so
yeah, okay.
the total becomes negative. Any questions? Okay, so I didn't go forward in the book because there are many examples. So I reviewed a lot of things. Yes, and I want to stop again here. And I give you time. I don't know how much time is left. Yes, you have around half an hour. So I think it's good to go and try to solve those here. Follow the Google Classroom, so I don't add anything new to the lesson unless I just solve new examples for you. Okay. You can follow that. Yes, I will stop recording here. You can rest a little bit and then come back to your work. Thank you.